Hi class, me Mr. Morris, and I wanted to go through real quick a video doing covalent bonding Lewis dot structure notes for students who are out today. So to get started, a little bit of a refresher. Covalent bonds involve a nonmetal and another nonmetal that share valence electrons. I want you to note that covalent bonds can exist in three different things, not just in covalent compounds, but they do exist in covalent compounds. They also exist in diatomic elements. An example of that would be something like O2. Also, they exist in polyatomic ions, such as NO3, -1 charge, or SO4 with -2 charge, and so on. So covalent bonds exist in all of those, and we're going to be drawing something called Lewis dot structures. You've probably seen water drawn something like this before, where you'd have a red oxygen atom and two white hydrogen atoms. You may be seen it drawn in the stick form like this. Well, we're going to learn how to do those today. Okay, how to draw Lewis structures. The octet rule is that all atoms want to achieve, you can probably guess it, the word octet means 8 valence electrons, but there are a couple exceptions. So almost all atoms, the exceptions are hydrogen, is the biggest exception, wants 2 valence electrons. Then there's beryllium, which we don't really see very much, and then you've got boron, which wants 6 valence electrons. By the way, I did neglect to say this is for pre-AP chemistry. This is note number 28 this year. This is 2022. All right, our symbol for a bonded pair of shared electrons, that means that they're going to be shared between atoms, like you see here. It's represented by a line. Okay. If you've got a lone pair of electrons that are unshared, it'd be like the 2 on this oxygen right here. Those dots, actually there are 4 of them, those dots on oxygen belong only to oxygen. They're not shared with hydrogen. They're represented by dots. 2 dots makes a pair. What I want you to get from this is that a line represents 2 electrons. 2 dots represents 2 electrons also. Then we talk about the skeletal structure of a molecule. Okay. It's just an arrangement of elements that tells which element is in the middle. The element first mentioned, we say it's always in the middle. I want to correct that. It's not always in the middle, but it usually is. Okay. So you could change that to be usually. The element first mentioned is usually in the middle. There are a couple exceptions. If there's more than one, they're also in the middle. The easiest way is the smallest number. So for example, if you look at these down here, H2O, there's 2 hydrogens and there's only 1 oxygen. So the oxygen goes in the middle, the 2 hydrogens are on the outside. I wouldn't have you do something like HCN without some guidance. It's a little tricky. N2H4, I've got 2 hydrogens and I've got 2 nitrogens and 4 hydrogens. So the 2 go in the middle and the 4 surround those 2. So you're generally going to have 1 element in the middle and then you have multiple elements on the outside. That's usually how it works. There's 1 central atom and then all of the other atoms are connected to it in most of the examples in pre-AP chemistry. Make sure you know hydrogen is never in the middle. You'll see why in a little bit. Now let's practice counting electrons based on what we just talked about. This is 2, this counts as 2, so let's look at this one. You can see that these 2 electrons, then we have 4, these are also 2 electrons. So 2, 4, 6, 8 for the other line, 10, and then 12. I hope that you followed my counting there. 1, 2, 3, 4, and then 5, 6, 7, 8, 9, 10, 11, 12. Each line is 2. Each dot counts as 1, but we draw the dots in pairs. Okay. Then oxygen or water would be 2, 4, 6, 8. HCN, 2, 4, 6, 8, 10. And then this one, 2, 4, 6, 8, 10, 12, 14. It's counting valence electrons.